Hello neighbors. I'd like to show you this stereo panning tremolo I've built for guitar or synthesizer. I built this in the style of a Eurorack synth module, so it's the right height and at 16 horizontal pitch. I probably wasn't super precise with these holes, so it may not actually fit in commercial Eurorack rails. So I did do a test fit into the case that I built, which is just wood, and it fits great, so no need to worry there. I'll tell you a little bit about how this thing is made, and then we'll play with the knobs. So at its core, this is two of the common sound Tremulus Lune tremolo effects that I built on Stripboard, combined according to the schematic for the Tremulus Panneur. I think this makes that a Tremulus Panneur on Stripboard. So as we go, there's some terms you should know. The LFO is a low frequency oscillator, and we're going to pull it up on the scope here in a minute to make that a little bit clearer. The other thing we'll talk about are light dependent resistors. And I don't know if you ever had one of those night lights that automatically turns off when you turn on the light switch. This uses the same thing as those night lights. So they have high resistance when they're dark and low resistance when they light up. So I've made a couple of deviations from the schematic. I couldn't find the particular type of LDR, light dependent resistor, so I just picked the best I could. Also, I wasn't satisfied with how slow it goes in the stock configuration, so I tried substituting a 500K potentiometer for a 100K potentiometer here, but it caused other problems with the circuit, the LFO shaping. I couldn't really see, when I built it, I couldn't see the waveform coming out of the LFO, but I could tell that it wasn't a real linear triangle wave. So I had to wait until I could get my hands on the scope to troubleshoot it further. I probably should have spent that time looking at the schematic, but I waited till the scope arrived and to really explore the interaction between these knobs. What helped was when I did get the scope, I took a picture of the LFO waveform, and the fellows on the Synth DIY Facebook group were able to help me out. Like 15 minutes later, I bodged in a couple of capacitors to up the value in a particular spot, and now it's real symmetric in the 2 to 8 hertz range. So even with all the modifications, there are still some quirks. The LEDs that you get today are a lot brighter than the ones that were available when this circuit was designed. So combined with the fact that I'm using the wrong type of LDR, it's a little wonky. My gain knob, you only want to get it about to 9 o'clock, and you've probably overdone it. It still sounds pretty good. There's some noise content to it, but I think the way you would use this in a mix, you know, with the synthesizer and everything else, I don't think that'll be a factor. So I think I have things connected here. You should be able to hear this when I turn it up. Just pardon my reach. I'll go ahead and bring this up. So that's just a simple arpeggio from the Yamaha synthesizer I have handy over here. This is just the dry, unmodified, what's coming out of the synthesizer. Let's go ahead and turn that down for now. And now let's bring up the signal from the Panneur. synchronized right now. This is the sync switch. I'm getting ahead of myself. Let's do the knobs first. Here's the speed. This one's got the bodged in extra capacitors so we could go slower. Oh. We'll let the scope start up too. So here's the speed knob. I've got it pretty good right now, but it goes faster. There's a depth knob. Now we wouldn't be able to see this on the scope anyway, but this controls how deep you cut into the signal. This is the smoothness knob, and this allows us to transition between a triangle wave and a square wave. Now that the scope is up, I've got the LFO here in the middle with the left and right audio tracks on the top and bottom. So let's see that smooth knob. Not quite a square wave. Let's go ahead and bring that back around. The next one down is the spacing knob, and it sets the spacing on the LFO, which isn't super intuitive. Not exactly a symmetric effect. We'll put that back at 12 o'clock. The last one is the symmetry. So you can... This knob is actually affected by the bodging that I've done, so it's difficult to see it do much at all. Ideally, this changes the duty cycle. So now it's favoring the right channel. We can try to make it favor the left. These last two are the gain knobs. It's set pretty good for now, so I don't want to mess with it any further. Now, as I mentioned earlier, there's the sync knobs and the the sync switch and the phase switch. This is the phase switch on the right. Right now, it's at a 180 degrees out of phase with the left channel. We can put it in phase by flipping the knob, the switch. Now you'll see the LFO is in phase. LEDs indicating as much. We can also just go ahead and disconnect the right channel from the left in terms of the LFO and let it just go to town. Or we can dial it in how we like. So as you can see, it's a similar frequency there, but the right channel, it's not a linear. It's not nearly as linear looking as the rise. The edge just looks totally logarithmic, and it's an RC curve, I'm told, by people much smarter than me. But that's why I ended up with the bodges, so that at this frequency range it was more linear, and you can see that in the blue channel. It's a little bit better looking. So we'll go ahead and sync them back up. I think they sound better out of phase. So that's basically everything that's on the board. I didn't have the right kind of patch cables, so I'm using alligator clips. So this is the in and out, the left in and right in on the bottom, and then out on the top. I think that wraps up the panel tour. that I learned from this round. I think the biggest takeaway was just to leave margin on the panels. I had to throw away the first set of panels I built because they were just too crowded. I couldn't fit all the knobs on there. On the next build, I'm going to omit the header pins. We'll take a look at the back here. There are female header pins up here. They just got in the way. I thought that would help me when I was troubleshooting, but it's just in the way. It took up space on the board, prevented wiring. I had to break them because there wasn't enough room in certain cases. In the next build, I think I found a better fit for the LDR part. So one that's actually closer in spec should get these gain knobs performing as they were meant to. And I can also use a